excited to dive into this. So hello, welcome everybody. Today we're going to take a deep dive into the world of AI agents, a topic that everybody is talking about these days, and we're going to go a little bit deeper, hopefully, than some of the conversations. So, as anybody knows who's been working on custom agents, assistants, copilots, fast, reliable function calling is an absolute critical building block to building agents that are actually connected to tools, applications, services. But it still remains a huge challenge. Many applications have hundreds of APIs, and even the latest foundation models today, the frontier models, don't always do a great job. And we'll hear much more about that and where they struggle and why they fail. Today, we're joined by a very, very special guest who is one of the leading researchers working on AI agents and function calling in particular. Shashir Patel is a fifth-year PhD student at UC Berkeley and a member of the Sky Computing Lab, Berkeley AI Research, and the co-author of Gorilla, a project that is bringing state-of-the-art function calling capabilities and even more to the world of open source language models. Shashir brings a wealth of experience to the table. He has worked previously at Google Brain, Amazon Science, Core ML, and Microsoft Research in India. And I cannot be more thrilled to have him here to sort of go deep on this very exciting topic. If anybody in the audience has questions during this conversation, there's a QA tab in Zoom. Feel free to type your question in mid-flight. I'll kind of glance over at it if I see it, and I can interject during the conversation. I'll do it that, or we'll take it at the end. But feel free to queue it up as you have questions. Today we're just going to have a free-flowing discussion, learn more about this fascinating topic, the problems with function calling agents, why they struggle, and some of the solutions with a particular focus on the work that Shashir has been doing recently. So with that, Shashir, welcome. Thanks for joining us.
Listen, thank you for having me. That was a very generous introduction. Thank you so much.
So maybe to kick things off, because I always like to hear a little bit of, personally the story, the journey that folks have had kind of coming to this world. Maybe you could just kind of give us a little bit of a personal introduction, how you got interested in machine learning, got to Berkeley, maybe even, started thinking about this particular problem that we're talking about.
Yeah, no, absolutely. So I think I started with ML, well, beyond just education, but actually starting to do research and starting to use it as a tool in most of my day-to-day work at Microsoft Research, honestly. So this was around 2017, 2018. And for context, RNNs were vogue, and people had just figured out about vanishing gradients, exploding gradients. And so LSTMs and GRUs were just arriving, right? So very exciting times if you were in speech or any of the time series domain. Vision blew up much later on with some of the self-driving work, but roughly around the same time. So this was the context. And I start off by doing what most people would do, which is, can we build something cool, trying to use some of the time series data. We looked at, in particular, sensors. Can we use an accelerometer and a gyroscope to try and detect if people are performing any action? And we were like, can we now use this as a technology to then try and augment some capabilities in Xbox, and also at the same time trying to augment some capabilities in for visually impaired people, right? So visually impaired people have a walking stick. Can they perform some gestures on it? And can we have an on-device ML that can understand what's going on? So this was the context, right? So you can see very application driven, and at the same time, this was already bleeding edge in the sense you're trying to take some of the state-of-the-art models and try to put them on commodity edge devices. I think today there's a lot of I think really good hype around how do you use stable diffusion or put 20 tokens per second, 30 tokens per second inference on your Apple MacBooks and stuff like that. And our goal was back then, can we go much smaller, right? Like an ARM Cortex M0, something that you find Arduino Uno, like a Raspberry Pi class device, and how do you do machine learning in there? And so I think, yeah, that was when I actually started doing some research on ML. And like most other folks who have had a reasonably good career in ML, I benefited from having some really good mentors. So some of the folks, Pratik, Vivek, and Harsha at Microsoft Research, were very patient and I think they had pretty good pedagogy in teaching younger students, mentoring them, and how do you pick up some of these skills. Because back then, as is today, a lot of it continues to be more art. That's slightly, bending the curve towards science. So I'm picking this up is is not very trivial to do it the right way. And I think I had some very good mentoring back then.
Yeah, it's interesting. It sort of sounds like you've experienced sort of this whole deep learning revolution, which maybe started with the image models really being where it broke out, and then what can we do with it? How can we put it in end devices? And then we kind of, I guess we've more recently had this language model revolution, and then now I think we're moving. Well, we're saying sort of language modeling generally, also generative AI, kind of more broadly in terms of different modalities and this idea that you can generate things. But one of them, I mean, I think one of the most um, exciting things today is really sort of how do we make this transition from language models or these to agents or these models that can actually start to take action in the world, both take understand the world from an input perspective, but also reach out into the world and maybe even take an action into the world, which introduces a whole nother set of challenges. I mean, maybe you could just describe a little bit, like, maybe how you got into, or what the challenges are. I mean, how you kind of discovered, hey, this is a interesting research area, because I think you were a little earlier than most, and sort of the challenges that you saw that you started to do your research on, which we'll get into.
No, absolutely. So I think the context was this was sometime around November or December of 2022, right? So ChatGPT was cyber, it was pre-GPT-4, right? You could still use the chat completion APIs to talk to some of these models. And there was a few things that we noticed right off the bat, right? It was very clear to us that LLMs were tools, period, right? And if you remember, December 22, well, I think December 23, in fact, actually, is when there was like this massive hype around, oh, is AGI finally here? I think December 22, excuse me, but like, why do you need to connect tools? Do you think an LLM cannot do this in 6 months? And so like this was the phase. And our thought process was, well, that's not going to happen because we have seen how technology matures, right? Like you mentioned, when I started, there was RNNs, and then there was like a whole minor waves, right? Like then came the autonomous cars. We were supposed to have self-driving cars in 2018. And then there was this period
Took
of
a
auto,
while.
yeah,
Yeah.
and ML that can, you can fix a hyperparameter. So auto ML was that. I think we then had a brief phase of everyone going towards model-free RL, and there was a fair amount of ODEs, and we're now at LLMs. And so one of our takes was that, okay, this is look yet another tool, and the fact that it could do so well, for me personally, was not that surprising, right? So in my mind, AlphaStar or AlphaGo was one of those moments where we knew in 2016 that some of these deep learning models could become superhuman. And since
Mm.
then, so this first happened in the game of Go, and then with AlphaStar with a lot more games. And slowly but steadily, a lot of domains are being knocked down in terms of when the deep learning model became superhuman. So for us, the fact that it could compress information and give knowledge was, I mean, I'm not going to lie and tell you it wasn't like the results weren't amazing, but it was less surprising, if you know what I mean. All right.
Mm-hmm.
And this was the context. Okay, so we understand, okay, an LLM is a tool. Then this begs the question, how do we improve the utility of the tool, right? Now, roughly speaking, there are two ways how we can improve the utility of a tool. One is by getting more people to use it, but that's more of a distribution game, right? Uh, you may argue that there's little less science and novelty in that, in the computer science research domain. But the other side, how you improve the utility of a tool, is to connect the tools to other tools, right? It's if you can connect, your Slack to different bots, connect it to different tools, then the utility automatically increases, right? So we were like, okay, how do we do that? How do we now go ahead and connect the tool that we have, an LLM, into other tools? And that was like the genesis of the idea behind Gorilla. And then, once you decide this, then there's a few different implementation details. Do we think of it as, oh, are we going to build, quote unquote, an agent that can interact with browsers? Or are we going to go and look at the API land and like what's the right modality? But yeah, that was the key insight there.
So interesting. I mean, so I think we've all sort of seen sort of connecting LLMs to tools, right? OpenAI has the function calling or released function calling, which I think really popularized it. Even but before that, right, there was a number of papers, the React, Reflexion, sort of prompt-based approaches to doing function calling. And then once it was baked into the API, it became very explicit that we could do it. And then in the commercial product, ChatGPT, we saw it with plugins first, and then it's kind of morphed a little bit from that perspective. But it does feel like we're still extremely early, and maybe it hasn't quite broken out. So we know that that it is possible for LLMs to make function calls. People who are building copilots and assistants, you really want them to be able to connect to your application, for example. But so what, from your perspective, what are the main challenges that are holding it back? Why hasn't it sort of fully worked yet, or sort of fully broken out? If at least that's my that's my impression. Sort of what are the challenges, and then we'll talk to, I think you're obviously working on some of them, but from your perspective, you just sort of think about, is it the scale of the number of tools? Is it the latency involved? Is it just the reliability of the tools? What do you see as the biggest challenges to really connecting language models to tools and have them use them effectively to deliver value?
Yeah, so that's a pretty interesting question, mostly because we're also trying to figure it out ourselves. But Tristan, one thing that you mentioned, which I will double click on mostly as a vanity metric, is that when we did Gorilla, it was much earlier than plugins, right? So we started Gorilla and then came plugins. And we had a discussion internally, should we go the plugins route? And we were like, no, I think we should stick to this, train the model and then going down the function calling route. And you're right, there were some papers before, like I think the tool former was pretty popular and React is agent. But our observation was pretty clear, right? Like some of us do systems research. And if you look at some of the hyperscalers, like just take AWS as an example, just the compute and S3 API, I think has like 1,300 or something like that command line API calls, right? So the question is, you can't stuff all of this into the prompt. I mean, even if you could, well, then who's going to decide that you're going to use GCP first? Oftentimes, what makes LLM useful is the fact that they're so versatile and they're so diverse, right? So who's going to do this like narrowing down of the scope? And we were like, well, relying on the user is not a good idea, because oftentimes the user does not know what they don't know, right? Like if I have to do authentication, until maybe a year ago, I did not know about OAuth 2.0 as a way to do authentication, even though that pretty much runs most authentication
Is the
everywhere.
standard, but it's so complicated. Yeah.
Right. Because it's like, in my day-to-day, I don't really use it. And similarly, I had a friend who was trying to like build an app, and then he's like, well, okay, the only word I know is React, and where do I start? Right? How do I like, build a backend DB, etc. So oftentimes you don't know a lot of these services, and you also want help with discovery. And if you're trying to do prompting, then a part of the discovery falls on you, right? You have to narrow down the scope, and within the scope, the LLM can pick among the K different tools. So some of us build plugins for ChatGPT, and there it'll tell you have to give them a
I see. You don't
prompt.
even know what tools, right? You don't even know what tools to expose to it. It's not even
Precisely.
the universe of tools is unknown, even before you decide on what tool to use. I see. Yeah.
Yeah, precisely. Like in ChatGPT plugins, you have to go and select, I'm going to use OpenTable, DoorDash, etc. But at this point, I would argue a lot of people don't know, right? Or like
Yeah.
I wouldn't know which tool in a domain that I'm not familiar with. So anyway, that's the background and the context. Now coming to your question, right? So what's holding us back? I think there's a few things here. And this is quite surprising. I mean, we got to know of this when we, one of the reason why we built the leaderboard was a little bit to educate the people on where we are, and just for us to like measure how well is the community progressing along this direction. And today, simple function calling, Tristan. By that, what I mean is you ask a question, what's the weather in Berkeley? And there's a weather API in JSON format. And all the LLM has to do is to take the weather API, and then in the argument of location, put Berkeley, CA. That's it, right? So something as simple as that, or whatever format the API uses. And it's not complicated. You don't have to pick from multiple APIs. You don't have to like call the API twice, like in what you would have to do if you ask the question, what's the weather in Berkeley and Palo Alto? You have to call the weather API twice, right? Once each for Berkeley and Palo Alto. None of that. Even in the most simplest of scenarios, we find that the current state of the art model is accurate about 83% of the times.
Wow.
In
Even
other
with a
words,
relatively small number of APIs, you're saying just
one,
because maybe Berkeley, CA, is it California? Is it
precisely,
CA? Is it
precisely.
Berkeley? Is it a zip
Yep.
code? It
Yeah,
might not
and
know, or might hallucinate, might not follow the direction reliably, something like that. Yeah.
absolutely. And there are some errors that are irreducible. Like, do you put a space between comma and CA or not? So if I do Berkeley, comma, CA, is there a space between
Right.
the comma and the CA? So even ignoring that, right? Or I would say including that, there's a few more. Like even if you say in the description, it has to be city, comma, state in two
Yeah.
letters. LLMs tend to not be able to follow these instructions well. They'll tell you Berkeley, comma, CLIFORNIA, which is not the intended format, right? And my point is 83% may look good, but if you're trying to build a service that's wrong 1/5 of the time is not, it's not a very useful service from user experience perspective, right? And
Yeah, exactly. Especially
oh,
if you start chaining those, I think what, a lot of examples with it, when you talk about agents, oftentimes it's multiple function calls, multiple, a chain of decisions. And if everyone's 80% reliable, it's kind of game over, for sure. Um, so, you kind of described two things there. Well, almost three things. I mean, one is, discovering functions that you may not even know exist. Now that probably exists in a certain kind of open scope world of agents. Some people may have on this call may have applications where it's, they're trying to connect it to a very specific application, like the application we work with a lot of people trying to build copilots, and they have a more well-defined, often have a more well-defined surface area. Then even within those surface area, that we see this all the time, is most mature applications have thousands of endpoints, and often very complicated endpoints. If you're just trying to expose them to their current set of tool, and then you're telling me, okay, so we still have a context length problem, sort of a complication problem, and then you're telling me that even in a simple case, there's you're going to struggle even in the simplest case. So I mean, this is maybe a good transition point to what's this, what's the solution, or what have you been working on? So I know that a year ago, or a couple a number of months ago, read about the Gorilla project from Berkeley, and there was a paper on it, and also Open Functions, which was an open source model that had function calling capabilities. And then since then I think there's been a few other initiatives around the Gorilla project, such as the leaderboard that you mentioned, looking at benchmarking function calling. And I know that you've done some runtime stuff that we maybe can get to at the end. But yeah, maybe you could just give us a kind of a quick introduction to the Gorilla project, sort of, what is it trying to solve, and sort of what does it do? What
yeah, no,
is it?
absolutely. So the idea was, like I mentioned, was like, hey, can we connect these LLMs, and can LLMs invoke other tools and services and applications, right? So the modern web today runs with microservices. And so the question is, how do you now connect your LLM so that they can invoke each one of these different services? Like, can you have your LLM? Very relevant for us is sign up for a class if you're in a university, but oftentimes it's like, oh, can we have an LLM that interfaces what the user asks and determines what information is critical, and then plug that into a database. So next time when the user comes back again, they know which one to retrieve from the database. So this is like the read and write semantics to a database is one example, right? So that's what I meant by connecting LLMs to tools. It could be like DoorDash or Uber. If you say, hey, can you book me an Uber from home to office? And the LLM has to ping, say, your Google Maps API, call, identify your home and office location, and then go ahead and trigger an Uber booking to book an Uber for you. So this was like I would say the motivating goals behind the Gorilla project. And we tried a few different techniques, right? Prompting techniques, like we discussed, etc. But the short form of it is that we realized that the best way to go is to actually train or fine tune a model to do this, right? So our goal was, can we look at all the different APIs? And today, that sort of APIs is about, I think, 60,000. Again, all this is open sourced. This includes like all the hyperscalers, AWS, GCP, Azure, some of the CRM and service providers like Salesforce, ServiceNow, Datadog, and a lot of machine learning tools like Hugging Face, TensorFlow, Torch Hub, APIs, and of course, which we completely did not expect, but turns out to be very popular. Two fronts. One is dev tools like Kubernetes and Docker, which is a pain for many people to use, and finance APIs like Yahoo Finance, Bloomberg, Alpha Vantage, etc. So the goal here is the user comes in and says, hey, look, I want to do X. So that's the intent. And the LLM now figures out what the right API is. So there's no RAG, right? So you can use it with RAG or you can use it without RAG in zero shot, and then comes up with the right API call, which if you execute, you would return the intended result. So that's like the goal. And there's a few
And
different things you have to take care of.
just to make sure, I understand that. So, I mean, are you thinking about sort of in domain, you have a set of functions, now in your world, you are focused maybe on a lot of functions, sort of an open world of functions, but you're still sort of saying, hey, these are the functions that this model is going to be capable of, adding. That, I think, differs a little bit from, if I look at the function calling for OpenAI, where it's saying, hey, let's build a generalist model that can take a prompt that has function call definitions and generalize to that prompt to know how to call those APIs. So is it correct that when I think about the kind of the work that you're doing, you're saying, okay, let's say that we have a potentially very large set of APIs. You're using kind of common ones that are available to everybody, but it could be applied to a more, if somebody had a specific application, you're basically saying, hey, we felt we needed to go down the fine tuning route to bake that actually the knowledge of those functions and the callings, the knowledge of those functions and the behavior of those functions into the large language model itself, into the language model itself.
Yeah, I think that's pretty spot on. So this is end domain. So Gorilla is a recipe, right? So you take the
Gorilla is
recipe
a recipe, yeah.
and then try to like for example, some folks try to do for GraphQL, where you take some of the GraphQL APIs and then train an LLM to do that. And so what Gorilla solves is the discover. So okay, if you want to invoke APIs, right? There are 3 steps to it. One is to figure out which API to use. Second is to get the syntax correct. And the third is to fill in the right argument, so you're getting the right answer. Right.
From
discovery
whatever the
is
user asked. Yeah. Yep.
the discovery is, do I use Stripe? Do I use Wells and Fargo? Do I use Chase Bank API? Syntax is, how do I make sure you don't get a stack trace or your interpreter error? And the right arguments is, if I want the weather in Berkeley, it doesn't help if I get the weather in Palo Alto, right? So these are the 3 fronts. And with Gorilla, our goal was, can we take a fine-tuning based approach to solve in some sense all 3, and you get some benefits as well, which I'll talk about. Now, open functions is the one where you may not want to train the model, either because it's expensive, but oftentimes, increasingly, it's not because it's expensive, but because evaluating models is super hard, right? You always have to look at downstream metrics. Perplexity as a score does not mean much for your downstream metric. So with function calling, this includes open functions, the OpenAI, I think Gemini, and Anthropic, all the function calling is where you say, okay, I'm going to help you with discovery, right? So I'm going to either give you a list of functions in your context, or I'm going to like augment a RAG, which is then going to look at your prompt and then do the same thing for you, like maybe list out 5 to 6 functions in your context. And you as the LLM are now going to pick the right function and then fill in the right arguments and make sure it's syntactically correct. Right. So that's like the 2 distinctions between the 2 recipes. I think both are like,
yeah, I mean, maybe you could, I mean, these 2 recipes, I think a lot of people, in my conversations are sort of familiar with the prompting approach, and then, potentially augmenting prompting with a little bit of retrieval, because, we kind of know that everybody's been familiar with the RAG, and you can kind of imagine how you apply it to the prompt, the function prompt as well, if you have a very large function specification. I think less people are maybe familiar with what the recipe is for fine tuning. And generating, I mean, we all may have our open API spec or our GraphQL spec, right, of our API that we want this model to be well at. But what do I just give it that, or do I give it something else? And I think you had a sort of some interesting ideas on a recipe that maybe takes the spec, but then does something more with it. Maybe you could just describe in a little detail so for people in the audience who are saying, hey, if I wanted to do this myself and fine tune a model for my API, how would I generate that data? Hopefully I'm not just typing it all in manually myself to generate the training set.
No, absolutely. And I think right off the bat, all of our recipes is open sourced, right? So if you want to try it out, though, let me take this chance to explain conceptually what the high level idea is. So hopefully this gives some key insights or nuggets that people can remember. So the key process is the following, right? You start off by looking at a set of APIs. And like you mentioned, open API specs, Swagger files, or just even readmes or markdown files of the documentation is good enough, right? So step 1 is where you generate something called self-instruct data set. Now, if you think of machine learning as a tool, you're trying to predict Y given X, right? Given X, you're trying to predict what the Y label is. With self-instruct, we flip the process and we tell the LLM, hey, here's an answer, right? This API call is the answer. Can you come up with possible questions for which this API call could be the answer? Right. So you say, oh,
so sort of simulating the user almost, taking the API spec and then simulating a user, from that. A user question from that, and then I see what and then maybe even the usage has the actual, what might not have the arguments, but I guess in the documentation it might have the arguments, right? Yeah.
Precisely. Right. So you're doing this, and so the key point to highlight here is coming up with this intent, coming up with X given Y is slightly more easier than the other way around. And because people may be asking, hey, isn't this tautological? Isn't that a cyclic relationship? And the answer is one of them is a slightly easier thing to do. So you can ask a general purpose LLM, be it Llama 70B, be it GPT 3.54, whatever, right? You can ask these LLMs to say, hey, look, here's an output prompt, come up with, like you said, simulate the use and come up with a question. Now, there's a few more details here. So for example, if you give this open-ended, then the LLM can give you a big paragraph, or it can start on a story, right? So you also want to condition this with in-context examples. So, manually, you're going to come up with 6, we chose 6 as a hyperparameter. You're going to come up with 6 examples of potential human questions, like I want to send money, and use the PayPal API as an answer, right? So if I give you the PayPal documentation, the question here would have been, how do I send money? So you come up with 6 of these pairs of documentation and user prompt. And then every time you sample 3 randomly. So the sampling and 3 random is to introduce stochasticity into the process, right? So you sample 3 at random, and then you ask, and then you give the LLM documentation and say, hey, look, based on these 3 examples, here's a new documentation. Can you come up with a potential user question along the same vein of what you have seen before in your examples? And so what the LLM does, it's going to then give you a single question that for which the API call would now be the right document. And you can also ask it to come up with the right arguments for which this would make sense, right?
And it's pretty good. I mean, I guess one thing that you're assuming here is that it's pretty good at generating the right question. You know, if it has the answer, that it's not too hard, or it's an easier task to generate the question than it is to generate maybe the from a question to the result. And you're sort of taking advantage of that asymmetry there to generate this training data. Do you? I mean, you know, one thing I've seen, I think, in some of the coding contests is the actually executing the APIs. You know, sort of checking your work. Hey, did it? You know, you generate a function call and you sort of learn from the error, or you know, I guess I think you've done some syntactic. I mean, there's both syntactical checks and there's also, you know, actually executing things and sort of seeing, hey, did I achieve what I thought I was going to achieve, right? Maybe you learn the difference between, should I have a space in Berkeley between Berkeley and California or not? But you have to actually sort of try it before you can know that's how to use a tool. And certainly as humans, you know, there is some aspect of, hey, we kind of need to try things, and then pretty quickly you can kind of only a couple more, you know, couple tries, and you've probably got the format for the location to be done correctly. Did you do any of that as part of Gorilla, or is that something that you've looked at, or is
Absolutely.
what do you think
Yes.
about that?
Yeah. And so just in the example with humans, right, is that, okay, if you want to invest in the stock market, as an example, what most people tend to do, or at least the recommended way, is you start off with like some small game simulator where you just, try to make sure you're fine.
Right, back test it, yeah, or something, right?
Precisely, right? Where there's like low cost, nothing, or like even if you have to like go and start working, you're first trained in a university where you practice in like some toy projects and then you go work in the real world. So we adopted something similar, right? So we use something called the AST, an abstract syntax tree metric, which is an offline metric to test if the function calling is right or wrong, right? So what this is going to do is it's going to test if it's hallucinated, right? For example, temperature is a floating point value from 0 to 2 or 0 to 1, depending on which chat completion API that you use, right? If to call an LLM. If the LLM said use 5, then you go, well, wait a sec, that doesn't make sense, right? Or if there's like
Yeah.
rolling die, and then if the API call at a place where it says insert the argument for rolled die, it says 1 to 6, then it's correct. But if it says -5, then you're like, well, it's unlikely that you're going to have a 6-sided die with -6, right? So an AST tree will help you identify this, and which I think is a very useful metric for people to identify offline. But of course, what we also had to do is go and actually execute the calls, right? So this includes like, starting a virtual machine, tearing it down, starting a Kubernetes cluster, tearing it down, using rapid API endpoints to like, find out how many dealers are present in North America for Mercedes and stuff like that. So yes, the TLDR is you need both, right? In some sense.
So sort of synthetic data generation with sort of filtering. I mean, synthetic, I guess, self-instruct, taking a seed set of documents, sort of trying to transition it. I think, transition that into a format that's more akin to what, kind of simulating what a user would add, kind of the question of the user, then the answer that you may have gotten from the documents. But then maybe even after that, there's I guess there's there's a filtering step or something like that to actually kind of create that golden data set. That does lead, I think, into one question, which is, I think with fine tuning, and I think a lot of people are kind of intrigued about the benefits of fine tuning, and is it, should they pursue it? But and it's, certainly a bigger bit of engineering work to do it, in part because there's many different ways to generate the data, and then even once you have the data, there's many different ways to actually do fine tuning. Whether it's you're doing some sort of adapter approach, or whether you're doing supervised fine tuning on the whole thing, or whether it's more of a preference fine-tuning data set where you kind of maybe transition your data set into a good versus bad example. Did you have any lessons, I guess, as you think about fine-tuning, best practices to fine-tuning, both, I guess, from the data perspective, but actually I was more kind of transitioning here into the method of fine-tuning. Was there anything that you found in terms of you're trying to now inject real knowledge into the LLM, are there some sort of guidelines in terms of, hey, you actually need to follow this approach to fine tuning to make this work?
Yeah, Tristan, I wish there was a clear recipe. The answer is no, but there's some wisdom of the crowd that I think we have picked up. And there's a few things, right? One is this is a rule of thumb, right? And you can quote me on it, but it's not backed by thorough, say, ablations or stuff. But the one question that people tend to be asking a lot is how many data points do I need, right? More is better, but that's not really an answer. And so if I were to give a number, a rule of thumb, we think roughly around 40K data points for like a 7 billion model is good in terms of fine tuning, right? And I say 40K, but the lowest you can go is like about 10K, and the highest you want to go is somewhere like about 100K or more, maybe a little bit more. So I think that's like the rough rule of thumb in terms of how many data points you need. By data points, I mean like user prompt and assistant response pairs, tuples to train the model. And the other common mistake people tend to make is having extremely high learning rates. And learning rate is not, oh, use 1E minus 5, stuff like that. Like you want it to be a function of your pre-training rate, right? So what we find is that what we have found to be helpful is that it's when your fine-tuning learning rate is maybe somewhere between a decade or 1/100th lower than your pre-training learning rate. Of course, we like tend to, it depends a lot on are you doing continual pre-training or not and stuff like that, but that's the TLDR. There's a few more interesting stuff, which is one question you want to ask yourself is whether to fine tune or not. This meta question fundamentally comes down to how well can you evaluate the model. Oftentimes people are like, well, can we fine tune? And the short answer is, do you have an evaluation metric, right? That accurately captures what application you're trying to use. It's not cost. Oftentimes people get confused, oh, is it expensive? And I think today, if you do it well, you could fine tune like a 7B model for a couple $100. So it's not very expensive. Of course, this is like the best case, even if you assume there's a 10x margin, it's about 2000 USD, which is not very high given the nature
Not
of
very high. And then I think one of the things I saw, one of the things I saw with the Gorilla open functions was the latency was, you're a very much smaller model. The latency is much reduced. So you probably your inference costs, you're going to certainly save it on the inference costs for a real application down the line. What is your, so there's interesting, this sort of 40,000 examples. And, this is, I guess, thankfully, we're not saying we have to label 40,000 examples ourselves. We're saying we need a synthetic data generating process that generates 40,000 examples and I guess does it in a suitably diverse, we can get enough diversity, I guess, from that synthetic, and enough quality from that synthetic data generating process. I think one of the things our audience probably, like their application is less about a general assistant that talks to all APIs. It's really saying within the context of a specific application, right? Think about Microsoft Copilot or something like that, right? The APIs are quite large, right? And most, many of the applications that we deal with at Continual, they're quite large API surface areas. Sometimes we, you say, hey, maybe you should narrow it a little bit, but often it's, hundreds, if not thousands of potential API calls. Some of them then can be pretty complicated. Really hard to put it all into the prompt on GPT-4, right? It gets expensive, gets slow. You can try to do some sort of RAG thing there to make it a little bit better. But a lot of people are asking, hey, should I fine tune a model? Is your sense that, if you have a specific domain with a fixed API, I guess what's your sense today? I mean, if you generate 40,000 examples, I mean, are you going from 80% to 95? I know it's impossible, or 99. I mean, is it a solved problem? Is it still a challenge? Do you have any,
so it's so
or you just
Chris,
have to
that's a
do it?
pretty good question. So one is it's hard to do apples to apples because you can always one thing that people tend to do is, can I give 3 in context examples in GPT-4 and try to improve performance, and you get like a few percentage points improvements there. So you can actually like start picking and sometimes pennies off the floor and improve some of the general purpose LLMs providers as well. But I would argue that the arguments here are slightly different, right? If you are using a real application, you cannot afford to deal with the varying latency. And I don't mean this in terms of the provider itself, they're trying to do some load balancing, trying to do batched inference. But the whole point that oftentimes you can get an LLM for a given question, a 1-word response or like a 500-word response. You could use like the stopping criterion, but then you get half the, it's not a logical conclusion, right? If you say here's the number of maximum generation tokens. So my short answer is there's a lot of reason you should fine tune, right? As long as you have a metric to verify how good your model is post fine tuning. And the reason you want to do this is because A, you get really good guarantees. You can train the model to either give you short answers, just call the API. Oftentimes we have people who say, look, I want the API, and I also want some quote unquote interpretability. Like, can I tell the user why I picked this API? So it gives them more confidence in pressing, okay, call this API kind of stuff. So you can like do a lot of behavioral massaging, right? You can say, look, I want this exact behavior. I want a single line of API call, and then I want maybe 3 sentences of justification to pop out to the user. Or you can say, look, I want this API call, and I want my output response to include like a defined function, call function, defined log, or like a very methodical, modularized output. So for a lot of this stuff, without deviating too much, I think it becomes critical to do fine tuning. I haven't seen very many tricks in prompting where you can get really good structure following.
And I think and in the case of open functions, it was a 7 billion parameter model. You were doing that with a 7, because one of the things I think that jumped out, everybody who's in the audience, you can check out the Berkeley Function-Calling Leaderboard, and you can see, I think in that context, GPT-4 still is maybe king, but the latency is just dramatically different. It's something, on the order of, sort of 2-second latencies, which I think from an interactive user experience, especially when you have a couple calls and then you have a response, you end up having, it can end up feeling pretty slow. And I think you were, sort of very significantly sub-second, in the leaderboard with open functions. So that latency aspect is I guess, which is associated with cost as well, but also I think from a user experience, latency is a big payoff that you're seeing.
Absolutely, yes. And this is not just mean, right? Even if you look at P95, because the user experience matters down the tail as well. And for a lot of these providers, you see vast variation between your mean P90, P95, P99, so on and so forth. And whereas if you have like a fine-tuned model, it's very easy for you to like contain the sort of variance.
I think one question that I often get from folks who are thinking about fine tuning is, are we just fine tuning a function calling model, or we are fine tuning a model that also is generating the responses, or we're sort of separating these things? I mean, in part, you're often with an assistant type experience, the user types in a question, it generates some responses, then the answer comes back. You get some function calls, but often there's a sort of a synthesis that comes back to the user, like the weather is 83 degrees or something like that. Do you have any, best practices here? Do you think the world, we should have multiple models, a small model that's sort of doing the function calling and making decisions, but then, you kind of throw it over to, I guess, GPT-4 or Claude or something to kind of give that the real sort of play the role where it is strongest? Or do you have any, I mean, I don't know if it's there, you saw catastrophic forgetting or kind of sort of degrading performance on other tasks once you start to fine tune, and therefore need to split things up. But I know this sort of like multiple model question has come up a lot when I've talked to folks who are thinking about this.
Yeah, Tristan, I think the short answer is unless something drastically changes, I think we are going to go down the multiple different models route, right? And the way I think about this is as sidecar LLMs. Right? So you have one LLM at the center of it, which is responsible for doing just the coarse-grained planning and some reasoning. And you have your sidecar LLMs doing a bunch of other stuff, right? And a lot of people think sidecar LLMs is just function calling, and the answer is no. Like, okay, function calling maybe open functions, or GoEx is one of those models. I think Bloomberg very famously came up with their own like model for some of the finance APIs, but even other stuff, right? Like long context. If you want to do long context, today, there are techniques where you can make the model long context, and you immediately see its performance on GSM 8K tank, right? So it
Right.
loses reasoning, it loses mathematical abilities, so on and so forth. And similarly, you can make a model that's extremely good in different languages for translation, being more natural sounding for the user, and then you see it tends to lose another capability. And can we, does scale solve this? Probably, I don't know, right? That's TBD. But I think in the next couple of years, at least, the way at least we think it's going to play out is you're going to have like this one orchestrator and then the different sidecars. And I also like this because this is how systems have evolved today, right? Your if you go to Amazon, it's not one, I mean, the UI is one monolith, but the backend is never a monolith application. There is a service for shopping cart, there's a service for checkout, there's a fraud detection microservice that's running, there's an inventory microservice that's completely different. This also helps with fault isolation, right? It also helps with like modular deployment and incremental deployment, so on and so forth. So yeah, given how we structure software, I think the sidecar LLMs, and it's not to say there's one main LLM, like you could have another small LLM for reasoning as well, but TBD,
Interesting.
them
Yeah. But
working
these sort of
together.
systems of multiple models, yeah, that
Yes.
that are potentially specialized and may have some advantages. I mean, not also somewhat from a from a technical perspective and from an engineering perspective. I mean, I guess, or from a machine learning perspective, but also from an engineering perspective. I mean, that's an interesting transition to multiple models. Then I think one huge topic now, I think maybe more on the sort of forefront, is this kind of question around multiple agents, right? You see this in ChatGPT, where they've introduced these custom GPTs, and you potentially have these specialized one, and you kind of talk to them. Even the way some of the I think the image models work, if you look at how DALL-E actually works in ChatGPT, it's not really a function call. It's actually the little sub agent that is massaging your prompt and putting some guardrails on it and then generating an image and then returning it back. And so it's sort of now a system of multiple agents, which where you're now communicating, I guess, via between these different agents with natural language versus, I guess you could say, why don't you just throw all these functions, all these different agents have capabilities, image generation or whatever it is. Why don't you just sort of throw that all into one agent or one language model? What is your sort of take on this? Your perspective on sort of this balance between sort of one agent with many functions versus, hey, maybe decompose it. I don't know where the boundaries, where should the boundaries be, or how do you see this? Is it similar to what you just described, or how do you see it?
Yeah. Kristen, one of the things that you mentioned is think of these agents in terms of capabilities, right? The way I would like to think about it, which has at least helped me, is to think of these agents in terms of who's deploying it or who's delegating it, right? An agent that does everything is going to be very less useful for, say, a PhD student. I would say it's going to have a completely different use case for a PhD student than maybe for you, than maybe for someone else, right? So the question you might ask is, okay, who's deploying this agent? If you go to like a AT&T or T-Mobile store or on their webpage and they have an agent, the goals and the form factor of that agent is very different, right? Independent of the
Right.
capability. You may augment it with the best multimodal stuff there, but if all it's supposed to do is like interact and show you the best plans, it's not the most helpful. On the other hand, for someone who's into sales, you may give them all the capabilities of mathematical reasoning, but more or less what they might want is more integrations, right? Oh, can it talk to all my CRM tools? Can it like, ping me a Slack message every time a DocuSign has been signed, or you get the point, right? Or can it like send Calendly, set up meetings, remind me when I have to follow up leads if you're an account manager and stuff like that. So I think it depends a lot on who's deploying it. And the interesting part here is you may have different categories of folks deploying it. By this, I mean individuals, right? You might want an agent that does X for you every morning, etc. Or you might have an organization deploy an agent for all of its users internally. Or you might have an agent that an enterprise or like a B2C deploys for its consumers on their web page. So I think thinking of it in this framework tends to help me understand better, because then it's very clear, right? So you have a goal and there are key capabilities that you want for this goal, and that matters more to you, right? So if you
Mm,
have agent that's supposed to like interface my email, then it I could not care much about translation as much, right? But I would care more
yeah.
about it to understand time and stuff like that. Like, can it connect to Google Calendar or like Outlook and stuff like that? So that, yeah, hopefully.
Yeah, no, definitely. I think as we think about as this whole world unfolds, and this idea of multiple agents, it seems inevitable. Although I think we're in the very early innings of this. We have about 15 minutes left. I want to make sure the audience, if anybody's in the audience and has a specific question, you're wanting to get the insight extracted from Shahir about that he's done from all his hard work. Please post a question in the Q&A, and I'll sort of keep my eye on it, and if I see it, I'll make sure to do it before the end. Um, I want to talk about some of the work that you've been doing. You've been doing some new work that's on some different topics. But before getting to that, I want to talk a little bit about your kind of view on the future, and sort of what you're excited by. But before doing that, the Gorilla project, we talked a lot about fine tuning. Is there any other sort of core insights, tips, that for somebody who's thinking, hey, I want to build an incredibly capable agent for my use case, for my domain, that I'm hearing, hey, fine tuning might be worth it, latency, cost, performance, all that stuff. You can do it, and then synthetic data generation with some quality filtering is a good recipe to do it. But are there some other kind of core insights? I know you've done some things on retrieval, fine tuning to kind of, well, you've done a few other things in this area, and I want to make sure if you have some insights, let the audience know.
Yeah, I think another interesting aspect to keep in mind is the varying nature of how often things change, right? So for APIs, for example, right, freshness becomes key. If you want a service
Mm.
to go beyond demos, and that's I've found a common mode where demos tend to fail, is they're quite brittle, right? So one of the key things is if you're trying to build agents, is that the agent has to be cognizant of an continually changing world, almost on the day-to-day basis. Right. And so when we use some of the techniques from what we call RAT, which is retrieval-aware training, is basically that. Like an API may change, V1 may become V2, some things may get deprecated, there might be a new API that comes online. And so the question here becomes, well, how do I take some of these changes frequently and then try to make the LLM robust to that, right? So one example is, if you bake in knowledge well enough, then if there's any noise in the documentation, LLM should be able to ignore it, right? So if a RAG system said use ResNet 79, I would expect the LLM to go, well, wait a sec, I've seen a whole bunch of ResNet models. I've seen ResNet 50, I've seen ResNet 101. I haven't really seen ResNet 79, so this might be uh, a noise in my retrieved data set, so I'm going to have lower confidence in that. So, stuff like that. Like, can we use the LLM, right, beyond just retrievers or beyond just syntax, to also reason about and like copilot and help the user in trying to understand what's going on. And by doing this, you're also making it pretty robust, right? So tomorrow, if there's another new model with a different backbone, you know, ResNet, then it can reason about and think, well, does it make sense? Does it not make sense?
So retrieval, you mentioned retrieval-aware training, and it sounds, I think many of the audience are going to probably triggering, hey, I'm thinking there's a RAG here going on. You're looking up the latest function definition, and then you're using that. But I think you're going beyond that. You're saying that there is not, maybe that's one way to get freshness, right? Obviously, just do prompting and do RAG. But you're sort of taking this to the next level and saying, actually, there's a training approach to this as well. Maybe you're doing RAG. But yeah, could you just, maybe there's a recipe here. I think this is a retrieval-aware training. I think it's a paper that's public. So if folks want to look at it in depth, they can do that. But what was the core kind of the recipe there, and the core problem and the
So
core recipe there
I can motivate by giving
you had?
examples, right? So retrieval-aware training was the idea we introduced in Gorilla, and we realized it's so powerful that we wrote another paper called retrieval-aware fine-tuning that's more general purpose, beyond APIs to including your documents. So the TLDR is if you're doing RAG, you should be doing RAFT, right? So what's RAFT? What's retrieval-aware fine-tuning? Let me give an analogy with taking an exam, right? So Tristan, some of us are students, and if you assume an LLM to be a student, and if you were to say, look, I'm going to administer an exam to you tomorrow, right? One way to prepare for this exam is by studying for it. And so in my mind, or the analogy is fine-tuning for LLMs, right? So where you're preparing for the exam by studying, you're memorizing the content. Another way is you go in and they say it's an open book exam, right? But I'm a CS PhD student. If you take me to an open book exam in the law school, and you give me all the textbooks in the world that deal with law, I'm not going to do too well, right? Because I'm not going to have any
Right.
idea given a question which textbook to refer to. So for us, the open book exam is an equivalent of RAG. But you're asking the LLM a question and you're giving it a bunch of context, especially with the long context. And the LLM, it's very hard for it to figure out, okay, which of it makes sense, right? So RAFT is a recipe where you're going to lightly study for the exam, for the open book exam, right? So if I go in and I have an index of all the different textbooks and all the different chapters, then given a question, even in the law school, I can quickly figure out which chapter it is on, and I'm going to do slightly more, much better. Well, not slightly, but I'm going to do much better, right? Or at least that's the hope. The same,
Yeah, that
yeah,
makes
the same
sense.
is with
And so not
LLM.
just and not just to sort of fine tune the retriever, like the sort of embedding, maybe the embedding and making the embedding, what page you go to, but even once you get the page, do you know how to interpret that page? Is that page applicable to your question? When you're reading it, so you put that all into the context. You may have some ones that are completely not applicable, even though they maybe are semantically similar. And you need to be able to sort of have enough background context, if I'm understanding what you're saying correctly, to be able to sort of filter out those distractors and focus on that. And did you see a big, I mean, is the net here that there was a big performance improvement if you did this, or what was the takeaway?
Absolutely, absolutely. So
Yeah.
by doing this, you can like across, like especially when you have domain specific knowledge like medical documents or like legal documents. So PubMed is data set for medical documents, across legal documents, and even general trivia, Wikipedia style documents. You see like a significant multiple percentage points, oftentimes, you know, in the lower tens percentage points improvements in performance if you were to do Raft.
Very impressive. Maybe we have 8 minutes left here. Maybe we'll do a little bit of a sort of lightning round-ish with some questions. So one is, I know we have one question, which I'll get to in a second. But I know you published a recent paper on the GoEx, which is sort of a little bit away from what we're currently talking about, but sort of a next stage of that. I mean, maybe you could just briefly describe, this GoEx paper, what you're trying to do, thinking about execution of these functions and sort of issues around that. What's the problem, and what's the idea behind that paper?
Yeah. So Tristan, the way we look at most of the agentic systems today is humans are ultimately the ones who are either verifying the process or they're verifying the output, right? Now, by doing this, I argue that the human is actually the bottleneck here, right? So what we suspect is going to happen in the future is going to have different agents and services and applications talking to each other with punctuated human visibility, right? So the goal is, can we take human out of the loop? You're going to have agents working on your behalf. It's going to keep doing a bunch of stuff. And then ever so often, you can go and check what's going on, but you can't consistently see what's going on. And in my mind, that's a perfect scenario because then in some sense, you've automated a lot of the things, right? Well, what's wrong with this? Everything, right? So one is, you're only able to see downstream applications and you get to know only a delayed signal. So if you have a delayed signal, like, you have an agent that I deployed and they did a bunch of stuff, people are unhappy, they're all screaming, now what do you do, right? The action has already
Yeah.
been done. So it's like post facto. So our goal is if in such a scenario, if things have already happened and you only get delay signals, how or what does it mean? What would the world look like? And what we argue is that we should still do this, but we need to give two abstractions to users, right? So the first abstraction is undo semantics. If I send a Slack message, people are angry about it, can I delete the Slack message? So to every time an LLM performs an action, can you give undo semantics? And you want all the good properties of commutativity, you want it to be associative, and then you also want it to be atomic. So you can either do a bunch of things and then remove it versus not do it. But
Right.
not
Would
everything can
make
be
it much
undone.
safer. Yeah.
Absolutely. But not everything can be undone. Like if I send you an email, well, you can't really undo it. So in those scenarios, can we define blast radius? Can I say, look, I'm only going to send emails to people who report to me and not to the people whom I report to, or stuff like that. And you can think of in an enterprise or for users, they can specify and say, look, I'm going to deploy this agent for people to talk to, and I want to set a dollar value. Every time a user does something, it should not cause harm more than 5 cents. And so now the question becomes, how do you take this dollar value and then translate that into policies that you can enforce so that you actually adhere to this dollar value? So that's the goal,
That's
right?
Yeah, that is really fascinating. I think one of the things that always haunts me about agent work, the work around agents is this just intractable? Ultimately, if I get an email and I read the email and the email says, send me your send me your password to your production system or something. Hopefully, my agent who's reading my email is not going to actually go do that. And is that an intractable problem or not? But right, something, maybe you can't actually kind of fully guarantee that with respect to the LM. But if you have a blast radius, so you could, never email somebody who's not part of the company, right? Or something like this, there or can you undo it? In the email case, maybe you can't undo it, but at least there's maybe a way to define that blast radius. I think it's a very fascinating area. We have a few questions here I want to do quickly. So we have one question that's, if agents are planning tools and memory, how do you think about planning? How does that relate to structured outputs? I think so. This is sort of the question of like, what's this line between function calling and planning? Where often for, like a coding assistant, you have a long-term plan you have to execute against.
Yeah.
Do
So
you think about, yeah, is it just the same
it,
thing or is it different?
no, it's slightly different, right? So for example, I stay in Berkeley. Suppose I want to go to San Francisco. The planning includes how do I go from my campus to the closest public transport station, take the public transport to the other city, and then walk out. This is a high level plan. And now to execute each of these plans, I can like maybe use individual APIs. I can say, hey, book me an Uber to get from my university to my local public transport system, and then buy a ticket on this public transport system to go to the next place. Right? So there's a planning aspect, and the planning aspect could be as course, or you might have to reason, hey, today is a Thursday, so maybe public transport is pretty frequent. Maybe Sunday is not so frequent. So you might want to use a little bit of reasoning and planning to do, figure out what your individual steps has to be. And the API calls are the ones, or like the function calling is the one that's going to actually go and trigger
Do that
certain
subsequently.
APIs,
Yeah.
to reach the state. Yeah.
Got it. Huge topic. I'm sure it'd be to just talk about what are the methods for thinking about improving planning, generally speaking. Another question was just to get to focusing on this on retrieval-aware fine-tuning, and the question was basically, what is the interplay between the embedded APIs from fine-tuning versus the retrieved APIs that you have at inference time available to you as I guess as part of the context. I guess that's the heart of it. Is this a better together type story, or is it
Absolutely.
and
It's better together, where your fine-tuning is like teaching it more knowledge and what to ignore, what to include. And your retrieval time is to bake in any new API that came up, freshness of data, so on and so forth. Right. But having said that, if you train a model to call Kubernetes API and then you give it a banking API, it's not going to do too well. Right. On the other hand, if you train it on like a set of one bank's API, and then at test time, at retrieval time, you use another bank's API, the model is going to be reasonably okay. In fact, the performance may slightly improve, right? Because it knows to reason about what API may do well. And like oftentimes it can reason that, hey, check balance is mostly a read API from all that I've seen. So that's reasonably less harmful as opposed to maybe transfer or some other API. So a lot of knowledge is transferable within a broad category of domain. But across domains, it's not really that helpful, right? So in that case, you're trying to be a distractor and you're like actually hurting each other.
Very, very fascinating. Well, we're almost out of time. I guess last question would just be, where do you think we're going to be at the end of this year? Or sort of what timelines are we looking at for all of this? And is there anything particularly, maybe, if you don't want to just give it that generic, is there anything in particular in the research world that you're excited by, either something that you've worked on yourself or something that you've seen out there, that's getting you particularly excited? So maybe kind of a timeline, kind of general sense of what's your timeline. You think this is going to take a long time to sort out, and then if there's anything particularly exciting that we should be paying attention to, what's coming next?
No, I think there's like two axes, right? One is in terms of the deployment and where folks are. And I think today most people are very comfortable deploying like chatbots and read-only operations, and they're slightly getting more comfortable with copilots. This is beyond just GitHub Copilot, right? So I expect a lot more of copilots by the end of the year. But on the research side, I think it's going to be quite fascinating. I expect two things to happen, right? One is reasoning is going to improve by a fair amount. And you can see like, models do Math Olympiad style problems pretty well. So I think that we're going to make a whole bunch of progress there. Or at least we have been like headed towards that direction. But the second direction is I think we are going to head slightly more and more towards autonomous agents. So Copilot is where it's with the human, right? So that's the core part of Copilot. Whereas in autonomous agents, it's like, I want to do some small thing, and can I automate it, especially for like, producing reports every quarter or stuff like that. So yeah, on the research side, I think autonomous agents and reasoning are pretty interesting places where I see a whole bunch of action, or at least a lot more resources are being poured into it. And on the deployment side, I think more and more adoption of copilots as we go.
Yeah, no, it's certainly going to be exciting to see what happens over the next few months and certainly few years. So with that, Shashir, it was an absolute pleasure having you. There was a lot of nuggets in there. Thank you so much for taking the time. Everybody in the audience, if you do have any questions, either for Shashir or about Continual, you can shoot us an email at hello@continual.ai, and we can forward it along if it's for Shashir, or we can kind of talk to you about your particular application if it's about what we're doing at Continual, which is a lot of related topics to what we talked about today. So thank you so much, and thank you everybody for joining us.
And thank you for all the folks who came, and thank you, Tristan. This was super fun.
My pleasure.